Hi all. Sorry for the long absence. I was actually interviewing for positions, so had some very cool openings that I was interested in, and so that was the reason for my absence. But let's get into 201, bitwise and number of ranges. So this is a bitwise Leetcode problem dealing with primarily binary numbers. And the description goes as follows. Given two integers left and right represent the range left and right, return the bitwise and of all the numbers in the range inclusive. So a little refresher on what binary representation of numbers is. Let's represent 4. Let's represent 5. This is 5. This is 6. And this is 7. We can see that the bitwise result of this and is going to be the first column is a 0 because there's a 0 present. The second column is also a 0, and the third is a 1. This equals a 4, and so the result is 4. Cool. Awesome. So what's one way? So actually what they're asking us is quite literally to iterate over all the numbers in the left, from left to right, inclusive, and starting with, I presume, a number that is big enough to hold all of these numbers and is filled with all ones, continuously do AND operations on it. So if we start from the first step, if we were to do an AND on this initial step and the 5 that's given to us, we would just have this number. If we were to do AND this number, we would get 0, 0. And finally, if we were to AND it again with this, we would get our number desired, which is 4. I'm wondering if there's a better way to do this, because it seems that the constraints here aren't very limiting. They basically say that the biggest number can be 2 to the power of 31 minus 1, which is a pretty significant number, so we don't want to do it in O of n. Let's look at some properties of binary numbers that could help us. Could we somehow automatically look at all of these columns basically one by one? I'm thinking. Is there a way to look at all of these numbers? What if I was to do some bit manipulation, mainly shifting this left and right? I could do that, right? Right, if this is a bigger number, I wonder if how are these numbers represented? Let's take a look at how these numbers are represented. I will pull up Python bitwise specification of a number. I want to do for I in range left, right. I want to print, and let's see what this is going to be. Binary. I can print this in binary. Binary of I. Return 0. Let's see what this is. I want to see those previous numbers that I was referring to. 1, 0, 1. From left to right. Why am I getting more numbers than I want? I think that's because of my test cases overlapping, actually, because there's, for the first one, there should only be, what, 3 numbers printed? Or even 2. Let's say right plus 1. Yep. 1, 2, 4. Okay, so they're also in big endian format, meaning that the most significant number comes first. The most significant number comes first, then could I do right shifts until I get this same prefix? For example, let's have a shift. Let's keep track of the shift, and let's say while left does not equal right, I want to print left and then do left shift 1, and then also do shift plus equals 1. Let's look at how this would look like. From my experience, or what I'm predicting is going to be 1, 0, 1, then 1, 0, and then 1. But if we isolate the prefix, we're basically trying to find the let's do this. While left is greater than 0. I messed up there with the how do I stop this from running? To refresh. While left is greater than 0, I'm going to shift it right, which means basically divide by 2, until we get to left equal to 0. We're also going to print left each time we go there, and so I should see 5, 2, 1, but in bitwise format, in binary format, this would be 1, 0, 1, 1, 0, 1. 1, 0, 1, 1, 0, 1. Do you see how each time we're removing essentially the right element from the right bitwise number from the original left? What I can say here now is while left does not equal right, I'm going to do right shifts for both left and right and keep track of them. At some point, left and right are going to be equal to each other, which is the exact time, which is the exact number that I need to print. What I'm doing here is I'm finding the same prefix on both left and the right, which is, due to the nature of the and, is going to result in the same number, because and a number and with itself is going to be itself. So as soon as I find the common prefix between left and right, and that's dictated by this is going to be the left prefix. Let's call this prefix, yeah. And the right prefix. At that point, all I have to do now is get it to the original, is left shifted the right number of times, which is going to be shift. Let's submit this, and this should be correct. Great. Awesome. Let's see if there are any more clever solutions. There. While left is less than right, I reduce right by 1, but that's going to be, that's not dividing by 1, so why is that faster? I think that this is probably the most intuitive and visually appealing solution, so I'm going to stick with this. On that note, thanks for watching. I'll see you guys tomorrow. Bye.